Now we need to sketch the curve with equation which will be given in a short while, showing the y-intercept and the coordinates of the minimum point. We need to sketch the curve showing the y-intercept and the coordinates of the minimum point. For this, we need to consider the original expression and the completed square. We have the original expression of the curve and also the expression, this same expression, written with the square completed. There we have our axes, and we are focusing on the first one, the y-intercept. In the original expression, the y-intercept is the constant value. Why is it the constant value? Because at the y-intercept, the value of x is equal to 0. Why is it equal to 0? Because the y-intercept is the point at which the curve crosses the y-axis. At that point, the value of x is equal to 0. As a matter of fact, the equation of the y-axis is x is equal to 0. But we can just be practical about it. Place 0 here and there in the place of x. These two terms will be equal to 0. The value of y will be equal to 8. For the minimum point, the y-ordinate is the constant value that is separate and apart from the brackets. This -4 will be the y-ordinate of the minimum point. Why so? Because this is a perfect square, and the smallest value that the entire thing can have is if the perfect square is equal to 0. There's no smaller value for a perfect square than 0. Therefore, we will have the minimum point on the curve when the perfect square is equal to 0. Therefore, if this perfect square is equal to 0, the value that we have is -4, and therefore that will be the value of y at the minimum point. What about the value of x? For the minimum, the content of the brackets is equal to 0. And that is why the perfect square will contribute 0 at the minimum point, because the content of the bracket must be equal to 0. If the perfect square is equal to 0, whatever we have inside of those brackets must be equal to 0. And what is the prevailing circumstance when inside of the brackets is equal to 0? X minus 2 is equal to 0. And if x minus 2 is equal to 0, then x is equal to 2. But that is not so sophisticated as solving an equation. If this is equal to 0, then the value of x that we have to place here for it to be equal to 0 is 2. 2 minus 2 is 0. Therefore, x is equal to 2. Because the value of x that we need for the contents of the bracket to be 0 has to be 2. Your x value is 2. Your point of concern is 2, -4, which will turn out to be the minimum point on the curve. We have both coordinates there at the moment. The coefficient of x squared is positive, which is this one we are showing. We are highlighting the 2 points that we are concerned with, and we are highlighting the coefficient of x squared, and we are highlighting the coefficient of x squared. The coefficient of x squared is positive. This tells us that the curve is U-shaped. We will therefore have a U-shaped curve that passes through the 2 points that we have there already. The curve has to be U-shaped, and it has to pass through those 2 points. There we go. x is equal to 2 right here is the equation of the axis of symmetry. The axis of symmetry is the vertical line that divides the curve into halves that are mirror images of each other. The curve is therefore symmetrical about the axis of symmetry. That is why it is called the axis of symmetry. The curve is symmetrical about the axis of symmetry. Download Richard James Mathematics Resources app from the Google Play Store and have all of your examination solutions, instructional manuals, and other electronic books and booklets in one place. Also, have all of our products and services at your fingertips and on the go. Call or WhatsApp 876-351-9689 or 876-318-8848 for all hard copy books and booklets to complement your studies. Significant discounts will be given to everyone who is registered with any of our programs.